Hi everyone, it's Christy, and I have to admit, I just love calculus. Why? Because it allows us to solve problems just like the one that I'm about to do. And stick around because I'm not going to solve this by just one method, but I'm going to solve this 2 different ways, and you can see just how fascinating calculus really can be. In this problem, we are going to let the region R be the area enclosed by the functions f of x equals 3 natural log x and g of x equals 3 halves x minus 2 as shown in the diagram below. And we are going to find the area of the region R. And like I said, stick around because I'll show you 2 ways to solve this problem. And if you haven't already subscribed, make sure to hit that subscribe button. I post weekly videos about calculus to help you in your learning of calculus. And so once again, if you haven't subscribed, make sure to subscribe so that you can see those videos and continue your learning of calculus. For this problem, I am going to use a graphing calculator. And it said f of x and g of x are already graphed in the diagram below. And because f of x is a natural log function, I know that has to be this curved function on the top, and then g of x is a linear function, so that's going to be this function here on the bottom. Now, whenever you find the area of a region, and in this case, it's this irregular region, we can't count the boxes, so that is why calculus is so helpful to help us find this. You either need to decide if you're going to take the top function minus the bottom function when you go to set up your integral, or you need to decide if you're going to take the right function minus the left function. And why is this problem so cool? Because I'm going to show you that you can actually use both in this problem. But if you'd like to look at a problem where there was only one option, either top minus bottom or right minus left, and you had to identify that, click here to watch that video, and you'll hear my explanation of why there was only one option in that case. But before we get to the good part of setting up this integral, we first need to find where these 2 functions f of x and g of x intersect. And to find that, I'm going to use the graphing calculator. As you can see here, I have typed in 3 natural log x into my first function and 3 halves x minus 2 into my second function, and here is the graph. Now it looks like I'm a little bit in the way, so whoop, there I go. I'm moving down a little bit. To find these intersection points, I'm going to press second trace to the calculate screen and number 5, the intersection. Where is my cursor? There we go. Let's find the value or the intersection point on the left first. And you can see if I move myself just one more, you can see the x and the y coordinates of this intersection point. I'm going to put this point in our graph so that we can use it later when we go to set up the integrals. And notice I have kept all the decimal places because I don't want to round until my very final answer. If I just put 0.7 or 0.74, 0.75 for the x coordinate, well then your final answer is going to be off a little bit. So in this case, just a little tip, I would write out all the decimal places of that intersection point. Now we need to find the second intersection point. So I'm going to go back to the graphing calculator, find it very similarly with second trace, find the intersection, only this time I need to find the intersection point on the right. And there is the x and y coordinates. Once again, I'm going to put that onto my graph because we will be using that in just a bit. Now for the fun part of setting up these 2 integrals. Like I said, I'm going to show you 2 different ways to solve this. So back up I go. There I go. And for the first one, I'm going to show you the one that I would probably use if given an option. And the reason for this is because both f of x and g of x are functions written in terms of x. So if I keep the functions as is, I'm going to write everything in terms of x, which means I'm going to do a dx problem. And therefore, I'm going to take the top function minus the bottom function. So when I go to set up my integral, I am adding up an infinite amount of rectangles. That's why I use the integral symbol from the first x value of 0.74, etc., to the next x value, which is the 4.206, etc. And once again, I'm going to take the top function minus the bottom function because that'll give the height of each of those infinite amount of rectangles. In this case, the top function is f of x, so that would be 3 natural log of x minus the bottom function g of x. And don't forget to put parentheses around that function g of x. That's a common error that I see. And then it is a dx problem. So the height would be f of x minus g of x, and the width would be your little tiny delta x or dx. That is the setup if you are solving this with top function minus bottom function in terms of x. And let's go ahead and plug this into the graphing calculator. And here we have it, but here I go, and we get an area of 2.471. So let me come over here and write that, 2.471, and that is the area using rectangles of where I take the top function minus the bottom function. Once again, that'd probably be my preference because as you see, the functions are already written in terms of x. All right, we're almost there. Like I said, you stuck around to see how I can solve this by now changing it in terms of y and doing the right function minus the left function. But if you've already found this video to be helpful to you, make sure to click that subscribe button so that you can see weekly calculus videos to help you with your learning. All right, this way is going to be a little bit different because again, I'm going to do right minus left. My rectangles are going to run horizontally, which means I need to add up an infinite amount of rectangles from the lower y value, which was the negative 0.88 value, to the highest y value, which is the 4.31 number. And I need to take the right function minus the left function, but I can't use the functions as given because these functions are in terms of x. I need to write the functions in terms of y. So if I take the first function, which was f of x equals 3 natural log of x, but replace f of x with just the variable y, I'm going to need to solve this function in terms of y. So let's divide first by 3, and then in order to solve a natural log, I need to change it to exponential form. So x would equal e to the power of y over 3. And that is the f of x function, but written in terms of y. Now for the g of x function, this is y equals 3 halves x minus 2. Adding the 2 over. And then multiplying by the reciprocal, I can see that x equals 2/3 times y plus 2. And once again, that's the g of x function, but it is now written in terms of y. When I go to write this integral, I am now going to take the right function, which is g of x, minus the left function, which is f of x. So that means I'm going to take this function on the right, the 2/3 y plus 2 function, minus the function on the left, which is e to the power of y over 3. And this is going to be a dy problem. So now you can see that's why I would have chosen to do the function in terms of x, but it's really cool to see that you can solve this by using right minus left or make it a dy problem. It's time to go to the calculator now and type this in. And here it is. Now, shh, don't tell anybody, but notice I use this with X instead of typing in Y because pressing this button that's highlighted in red on the left, pressing that X button is just a whole lot easier than trying to find Y on my calculator. So when I go to type it in my calculator, I do write it in terms of X. So I'm gonna move myself right on over here, press enter, and okay, how cool is this? We got the same exact answer, 2.471. Can you see how excited I am about calculus? I think this is so neat. So there we have it, 2.471. We get the same exact answer, just using a different way, writing it in terms of Y instead of X. And back over here I go. And that's it, everyone. You've stuck around to find 2 ways of solving the same problem, and we got the same exact answer both times. I hope you found this video useful. If you did, make sure to give it a like and comment below about any questions you have or any comments you have about this video or about this problem. And if you haven't subscribed already, make sure to subscribe so that you can see videos on calculus to help you with your learning. Until next time, everyone, have a great day, and we'll see you in the next video. Bye.